Hello everyone, this is hw from class EL6303. In this video, I will solve question 1 in homework 5. We are given that x and y are independent, and the density function of x and the density function of y. We also know that z equals to x plus y, since x and y are independent. When we calculate the density function of z, the first method we can use is the convolution method. That is, the density function of z equals to the density function of x convolved with the density function of y. Now, we already know the density function of x and y. Then we plug them directly into this formula. I will get u z minus 1 minus u z minus 2 convolved with u z minus u z minus 1. Then this equals to u z minus 1 convolved with u z minus u z minus 1 convolved with u z minus 1 minus u z minus 2 convolved with u z plus u z minus 2 convolved with u z minus 1. And because of the property of a step function that u x convolved with itself equals to x times ux. In this problem, it's also a LTI system. Then we can apply the shift property. The fzz equals to z minus 1 times u z minus 1 minus z minus 2 times u z minus 2 minus u z minus 2 times u z minus 2 plus z minus 3 times u z minus 3. For this part, we use convolution method to calculate the density function of z. In the second part, we will use geometric method to calculate the density function of z. First, let's draw some pictures first. Because z equals to x plus y, then we can find y equals to z minus x. Then we can draw the density function of x. Here, x is ranging from 1 to 2. And we can also draw the picture of the density function of y, where y is ranging from 0 to 1. Therefore, when z is ranging from 1 to 2, we can have this picture. In this picture, if we want to have the density function of z, we have to calculate the distribution function of z first. And it should be the area of the shaded. Then fzz equals to z minus 1 to the power of 2 divided by 2. And according to the definition of density function, we just conducted the derivative of capital Z divided by dz, and the answer should be z minus 1. If z is ranging from 2 to 3, we can draw the picture like this. For this part, the capital Z equals to z minus 1 to the power of 2 divided by 2 minus 2 times z minus 2 to the power of 2 divided by 2. And also, we conduct the derivation of the distribution function of z. In this part, we can get the density function of z is equals to minus z plus 3. So, when z is ranging from 2 to 3, and in it's this equation. And in other cases, the density function of z is 0. Actually, the density function of z in this form is just the same as the answer we can get from the part 1. In part 1, we used the convolution method, but in this method, we use geometric method. The answer should be the same. Thank you. This is the answer for question 1 of homework 5.